Hello, everyone. I'm Dustin Chemo. I'm a mainframe specialist here at Google Cloud, focused on modernizing and taking a look at ways to extend and to enhance and move workloads over to the cloud to take advantage of the capabilities that are there. And tying that right back into Ron's question, some of the reasons are for networking, for performance, for some of the other things that are there. Google has a huge investment in worldwide networking, like all the cloud providers, quite honestly. But you constantly are seeing, we're constantly upgrading, we're constantly building out new cables, we're dropping them under the sea and constantly improving that around the world. And as we tie in these legacy workloads, we find advantages of being able to do some co-location in data centers and extend them for different capabilities. And I'll get into some of that as we get going. I'll also hit on in a moment the question on the percentage of lift and shift versus refactoring, because we take similar approaches that was discussed, and I'll tie that in as well. So without further ado, we'll get started. We've got an action-packed hour with the mainframe, and then quantum and HPC with Kevin. So just to level set, and I think the folks that are here, and like John said at the beginning, we also kind of lump legacy into the term mainframe. So when we say mainframe at Google, we often refer to IBM Z, but it also picks up things like Unisys AS400, AIX, and some of the legacy workloads that run over there as well. But the mainframe is still everywhere, right? There's still the large accounts. The largest banks, the largest insurers, the largest retailers, and everybody still relies on the mainframe for running their workloads across the world. So 80% of the data is still there. We'll talk about that in a second. Over 30 billion transactions occur every day on mainframes. In fact, you'll see stats on Black Friday of credit card processors and things once we hit the peak retail season of workloads that are being run and how many transactions actually go through the mainframes. 9 out of every 10 banks are running on mainframes, and the usage is increasing with CIOs saying that they are constantly being faced with challenges of integrating new workloads, new applications, and new functionality into their legacy systems. So with that said, with those stats, we're just reiterating that the overall mainframe usage continues to increase, and you see including other legacy systems. So not just the mainframe, but AS400 and things as well. And you see the stats on the right here that 56% of decision makers are still using mainframes today, and you can see overwhelmingly that the workloads are increasing from just transactional volume of credit card transactions, retail experiences, and things that drive inventory, retail management, things like that on the mainframe continues to increase just with the workloads and the bandwidth that's required to support those. When we at Google take a look at mainframe modernization and transformation, we really focus on these 4 strategic priorities. It's increasing the agility, so providing the flexibility for the workloads that are going after data that still resides on the mainframe, for core applications that still run on the mainframe, finding ways to make those more agile so you can build them into your DevOps tool chains and work streams and workflows, and give the developers a consistent experience from the front end of the app to the back end of the app. Increase operational efficiency, so it's a very different model with the cloud than on-premise, and the modernization and transformation to the cloud provides this operational efficiency. And then the other 2 things are the reduction of costs and the reduction of business risks. So first off, just in terms of compute power, and it kind of ties back into the networking and the processing and the scalability and resiliency of that you can do with the cloud and expanding. You constantly have ways to not keep the excess capacity on hand on premise, move where you need to go, and expand for peak seasons, peak workloads, and things like that. And then the reduction in business risks are really focused around regulatory compliance, but also skills, and we'll talk about that in a second, about how skills continue to be a challenge for legacy platforms, and when you start to modernize and get into some of these more modern languages, object-oriented, and things that run natively on the cloud, that are more cloud native languages, it gives you less risk and more flexibility. And as I flip to this chart, I just heard this week that Python is now the most popular language in the world, which, funny enough, is also a 30-year-old language born in 1991. So even though we talk legacy and modernization, there's still some legacy in the languages and the code that we're doing today. So this is our Google's journey map on a page and kind of our approach to modernization and how you do it. And I'll walk through this, but as I talk through it and discuss it, you can think of this as a subway map, and we think of this as kind of the same approach to modernization and enhancing your legacy apps as you would take as if you were a person in Manhattan. We could be staying anywhere we want in the financial district, in Midtown, even up in Times Square area or whatever. But if we want to go anywhere, the first thing we're all probably going to do is walk down to Penn Station and jump on a subway. We think of mainframe modernization with having a similar approach to that, and always starting on that single track. So we always walk the same path from wherever we're at in Manhattan to Penn Station, but from there we can go anywhere. And we may take one subway or we may take multiple tracks to get to our destination. But our focus is really around the business objectives. So we talked about what are the priorities that you're doing, whether they're regulatory, strategic, reduction of costs or skills, and that's where we start at Google. Understanding in the environment, discussing the solutions of where Google Cloud can enhance and extend legacy mainframe workloads comes into play, and also with this value prop bullet kind of in the middle. So we have an approach, which we'll talk about in just a moment, that really focuses on determining the right disposition based off of the characteristics and the workload needs for the legacy workload to find what track it would fit on. And like I said, you may start on one track and then switch to another one at one time, take two parallel tracks in hand, and really kind of, we've developed a framework that's really about understanding the complexity and business maturity of these workloads to determine the best path to move forward, which ties back into the question around what percentage do we see on lift and shift versus a refactor. I think it's, not to give a non-answer, but your mileage may vary, and every workload's different. And so, there's often times where we need, we're working with a client and they need to get out of the data center. So we may use this red bullet in the middle, which is our region extension, which is to put in a hosted environment that's directly connected to Google Cloud for low latency. Or it may be that we could just recompile and run the workload in an emulation layer, such as Micro Focus. And I'll talk about our partners as we close out the mainframe track here today. So jumping to the right and going from the top down, the option to retain is always there as you do this transformation. You could find that you need to unlock some data and move some of the data from a DB2 warehouse or DB2 or IMS to something like BigQuery for AI ML capabilities and extending the application to do some analytics and workload that isn't cost efficient or available for you on your mainframe. So retaining and surrounding with APIs and extending it is always an option. Then we jump into the yellow track, which is the rehost, which is the emulation layer. I mentioned Micro Focus. There's Heirloom Computing, LZ Labs, Raincode, TMAC Soft. All are options that can do emulation. And when you run those, you recompile them, those applications. They have the same look and feel, but they can run natively on Google Cloud on GCE. The blue line is the refactor line, which there's a number of SIs, GSIs, and products that are available on the market, but we at Google pride ourselves because we are a cloud provider that actually has a proprietary solution called Google G4, and I'll go into that in a moment as well. And then lastly, the green line is a line that's always been available for mainframe clients as they look to the future, is the reimagine or rewrite or completely replace legacy workloads. So this is our journey on a page, and I'm going to jump to one more chart that looks kind of similar in this look and feel, but it kind of reiterates the fact that the track doesn't have to be a one size fits all, and you can find a starting point on the mainframe on a legacy platform, a legacy workload, and you can jump to where you need to go. I call this the leapfrog chart, but each option that's in that subway map, and the one that's not depicted on this chart is the retain and surround with an API, encapsulate and extend. But all of these options have different objectives that are served. You can see the regional location is maybe a quick data center exit. There's no impact, same look and feel, still runs on the same hardware. moving to the rehost with the emulation, reduces your operational expenses, but the tech stack's more standard because it's still the same look and feel. You can still have your developers do the same day in, day out type of workflows that they're doing. Refactoring is breaking down those legacy languages like COBOL to Java, and then Reimagine is completely building from the ground up and leveraging cloud native capabilities. Continuing on, here's a couple of examples. We're constantly at Google reiterating, redoubling down, working with clients and building rehosted and refactoring applications. So these are the two middle tracks are where we spend a lot of time. The yellow rehost and the blue refactor. But these are just some reference architectures of how we're building these out and taking advantage of extending those applications and then transforming them to be more cloud native. I talked a little bit about the application segmentation and finding the disposition for the right track of the mainframe modernization and transformation. This is our approach. We call it the MAPA, the Mainframe Application Portfolio Assessment, which we can do with our customers to help do some application survey scoring, understand the priorities of the workload, what the business impact is, the maturity, the complexity of it, the languages that are involved. And as we go through this assessment that we work through with our customers, we score the applications, and it helps us to find a disposition for on an application-centric level where we can determine what the application looks like, what it needs, what it requires, and then really kind of focus on where it would need to go, whether it's a retain and surround with an API, it's a rehost, and an emulation would be a great fit, or the refactor to recompile, automatically recompile the code into a modern language that can run there. And then it builds out what the mainframe impact could be. So, reduction of the operational cost, reduction of risks. It can quantify and determine those. So as you go forward, you have some data that can back the track that you're going on and show which one is the most viable path moving forward, and what is the true impact to the mainframe environment through this modernization approach. I've got a couple charts here about our Google G4 product, but we see this as a huge differentiator from the other cloud providers and the competition as we move forward in having this in-house as a Google owned and operated tool. So it's proprietary. It's something that's built in-house. It has major development into additional languages and capabilities, but not just for something like COBOL or assembler. We're also seeing a big growth push into areas like RPG and in the AS400 space to take advantage of those legacy workloads for transforming and automatically converting those. We see it's a true modernization. So it's not just a code converter in that it's taking the COBOL and putting it into Java that can't be maintained, it can't be run, modified, it can't be adapted long term. It's a true modernization in the sense that when you come out, the COBOL goes in, for example, or RPG goes in, and when you come out with the Java, what you get is a true maintainable, manageable, readable copy of the code. So it's not just a like for like, it actually is doing a true refactoring and compilation where it's a manageable, maintainable across the technologies and the architectures of where you're going. This is part of our partner network. We've got our own professional services organization that works with clients on this, but we're also working to enable our partners to be able to do this, and we'll cover the partners in a moment. And we see this as future-proof. This is a quick way to unlock, in addition to just moving data over to the cloud into BigQuery or Spanner or Cloud SQL to take advantage of cloud native capabilities. This helps get the legacy workloads and some of the business logic out of the traditional mainframe environment and to the Google Cloud, so you can future-proof your applications for things like AI, ML, just integration as new applications are being built, standardizing on languages, and so forth. So we see this as a huge differentiator for Google Cloud and how we're transforming legacy workloads. Again, this is another chart that just talks about the G4 capabilities here and the value prop of it. But you can see on the left-hand side of this chart, you've got the high costs and TCO, the knowledge drain with the support and skills and staff that's retiring and being able to understand the applications, be able to modify them. the long term to market and low scalability. As we go through the G4 tooling, we have a assessment and discovery process where it can ingest the code. It can determine interdependencies of the applications, how they run together, reads, writes of data, and so forth. So as you start to break down the applications as they sit today, the G4 capabilities can help to find islands of functionality that could be broken down into microservices long term as you start to move forward with the modernization and really kind of decompose the applications from monolith to microservice as you start over time. So there's the discovery, the assessment, and then the replatform and test. And you can see on the right all the benefits that you can get from moving to the Google Cloud platform, the ROI of less than 3 years or less. You get the agility, DevOps life cycles, and so forth, open source, and so on. And finally, the last chart or the last thing I wanted to mention on our G4 Google G4 capabilities was an ISG provider report, which was published in the springtime in the March or April timeframe this year. But ISG took a look at our tooling, went through and rated it, and the Google G4 mainframe modernization software came out as the leader in the top right of the quadrant. So you can see this report if you want on the if you Google mainframe modernization, you'll find our landing page, which has information on our approach, has information on our technology providers, and also a link to where you can download this ISG report and read more about how the Google G4 product fared and how ISG rated it as the leader for mainframe modernization software. Finally, as I close, I wanted to highlight the partners. So we have a wide span of partners and SIs, both as well as technology partners that we work with. You can see that we have service partners that can help with the delivery in support and with our own PSO organization that bring their expertise. We tie in very nicely with all the major GSIs in terms of our practices and orientation and how we can go to modernization. We have the technology partners. I've mentioned a few like Micro Focus and TMAX Soft for emulation, but we also have partners like Confluent for data streaming with Kafka, or Treehouse for modernizing and migrating data to the cloud. And then we have our own internal partner delivery that we've talked about with our PSO organization. And my final chart before I turn it over to Kevin to talk about HPC and quantum is, here's our rich partner ecosystem. You can see a number of the partners that we're working with both across the service delivery and technology stack. This is not all inclusive, it's not all extensive, but these are some of the major partners that we work with regularly on mainframe and legacy transformation. So with that, I thank everybody for your time. If there's any questions, I'm happy to take those. And if not, I'll go ahead and stop sharing and Kevin can